Okay, so let's say that we have a conservative force F, which therefore means that we can get it as the gradient of some potential energy function, U. So if we have gradient of U is equal to 0, we know that the force is 0. We can say that the particle that experiences this force field such that the force is 0, we can say the particle is in equilibrium at that point. The force is 0, the gradient of the potential energy is 0. Let's say that we move the particle from that point, and the particle tends to come back there. So the forces are such that the particle is pulled back to that point. So an example of this is the spring, right? So we have a particle of mass m attached to a spring, and it's pulled. We pull it this way. So let's say it's in equilibrium there, and we stretch it this way. It'll be pulled back this way, and it'll oscillate about this point. It tends to come back to that point. We say that that point where the force is 0 is stable. So we say it's a stable equilibrium point. So let's look at the features of stable equilibrium points. So we mentioned the spring, so we know that the potential energy function for the spring is 1/2 the spring constant times x squared, so one-dimensional spring. So du by dx is equal to kx. At x equals 0, du by dx is equal to 0, right? That's this condition, the gradient of the potential energy function is 0 there. So the force is 0 at x equals 0. And so that is a point of equilibrium. But notice also, let's plot u as a function of x. Looking for a different color. Can't find my regular marker, so let's just use this. So it looks something like that. So notice that this stable equilibrium point, right, because we know it's a stable equilibrium point from this analysis, we pull the particle to the side, the force will be this way, and when it comes this way, it'll be pulled that way. It'll tend to come back to x equals 0, so that's a stable equilibrium point. Let's notice also that at x equals 0, x equals 0 is a minimum of this u function, right? It's the lowest point of that function. And notice also that we have the second derivative of u with respect to x is equal to k, and that's positive. So the bending is upwards. Okay, so these are the features associated with stable equilibrium.